This is my Anatomy and Physiology assignment 2 by me, Callum Hill. So I'm going to be talking about joint classifications first. So as you can see, there are 3 classifications of joints, which entail fibrous, synovial and cartilaginous. The fibrous joint is only located within the skull, for which the bones are formed together to make the mobile classification of joints. Synovial is able to process articular surfaces being covered with hyaline cartilage. That is also known as avascular, non-nervous and elastic. It is also lubricated with synovial fluid that allows the forms of cartilage to be slippery for freer movement. And lastly, cartilaginous is another type of joint that is a piece of cartilage that is located between the bones that allow it to hold the bones together structurally, which makes a joint. In addition to this, cartilaginous is further divided into following subtypes. Now again, with joint classifications, I'll start with 6 joints. So we've got the ball and socket first, so a special classification of synovial joints that are able to enjoy free sense of movement in the body. The hip joints are the only ball and socket joints in the human body due to musculature, movement and supporting flexible joints. The hinge, which is a synovial joint again, that is located in the ankle, elbow and knee joints. Hinge joints are equally formed between 2 or more bones, only moving along one axis to flex or extend. The pivot joint is also a freely movable joint that allows only rotary movement around a single axis. So the pivot joint provides a twisting movement of bones within the forearm, which is radius in your ulna, against the upper arm. The condyloid bone is the oval projection or a hollow space directly opposite a placed bone, which is the purpose for movement within joints that become possible to move, although it cannot rotate freely. The gliding is a common type of synovial joint formed between the bones that are flat. The aim of this is to glide past another type of gliding bone in any direction along the plane of the joint. Lastly, the saddle is a synovial joint again, where only one of the bones is shaped like a saddle, with another bone resting on it like a rider on a horse. The aim of the saddle joints provides stability to the bones while also providing more flexibility than a hinge, which is similar to a condyloid joint. We're going to move on to the histology of the long bone, so this is also known as the locomotor system. Skeletal muscles work within the conjunction within the skeletal to provide support. In terms of this, it helps to support and protect pedicular skeleton involving movement. In terms of functions of bone types, which entail long, short, sesamoid, flat, regular and irregular. In terms of the compact and cancellous bone, the compact bone consists of hollow tubes called lamella, are made of collagen fibres. In addition to this, these tubes have collagen running opposite ways to enhance bone strength. On the flip side, the cancellous bone consists of honeycomb, which provides flexibility more than the compact bone. The bone and growth development of the long bone. So the formation of the bone during fetal stage of development allows in intramembranous ossification and endochondral ossification. The secondary ossification occurs after birth and allows the epiphysis of long bones and the extremities of the irregular and flat bones. However, bone development are remodelled throughout life to be able to regulate calcium homeostasis and the repairment of microdamaged bones prior to the shape of the skeleton during growth. As you can see, the diaphysis is central part of any long bone, and the epiphysis is rounded ends of long bones at its joins with adjacent bones. The histology of the cartilage. So in terms of this, it's strong, flexible tissue that allows compression and allows to rotate as well. So the hyaline, the weakest type, which is found within the rib, nose and trachea. The fibro, which is the strongest type, is found within the ligaments, joint capsules and discs. And lastly, the elastic, which allows shape and the ability to freely move, which is found in the ear, larynx, and lastly, the epiglottis. Ligaments, according to Marieb, is the ability to freely move that can stretch to at least 6% before any forward tear. For the ligaments, there are dense bands of collagen fibres within regular alignments, which also offer tensile strength. The cells are referred to as fibroblasts, which enables to strengthen during exercise. The histology of the tendons. So in terms of this, it's the most connective form of muscle tissue to the bone. It is also the link between the muscular and skeletal systems. It also transmits the force between the muscle contraction through the bone. However, it also allows to provide elastic energy. to help actions such as running. Lastly, training will be able to develop tendon stiffness. The areolar tissue, again, histology of that. It's the most common type of connective tissue, which is a more like a loose mesh-like structure. It is soft and gel-like, which has a primary purpose of being able to hold organs in place and offers a support, strength, and elasticity. Muscle actions. So in this theory, a muscle action is able to show forces within the muscle, affects the length of the muscle itself, which leads to muscles can be performed by three main muscle actions, which is starting with the concentric. So this exhibits tension and generally creates muscle forces to be able to push, pull, throw, and kick in. The isometric, which again it exhibits tension and also creates muscle forces to stabilize joints. Lastly, the eccentric. So this action exhibits tension and also creates muscle forces to control speed, which is used by accelerating by gravity. The proprioceptors, so we're going to move on to muscle actions now. The aim of this is the muscle action located in the joint. This follows on by muscles and tendons which detect to increase more tension and pressure, followed by processed subconsciously. Muscle spindles are primary proprioceptors within the muscle that allow sensitivity to change within the muscle length, that also allow to stretch your legs whilst walking or arms being reached for something. The Golgi tendon organs. So this is the aim of a muscle action that allows to sense information being received from the organs and tendons that senses tension. It is the tendon organ that informs you to how much tension the muscle is exerted. And lastly, the muscle spindle. So the muscle spindle is a form of proprioceptor, which is a sensory organ that receives information from muscles that also sense movement, such as stretching and speed. With stretching, there is a signal that passes through into the nervous system that would instantly react to stretching, but not as much. Stretch shortening cycle. According to Science and Sport, the stretch shortening cycle enables to refer to pre-stretch or counter-move actions that will enforce observation during human movement, such as jumping. The pre-stretch enables to instantly warm the muscles quicker in order to produce more force and the ability to move quicker. The sliding filament theory. So this theory enables to produce more muscle fibers at a basic level, made of up to myofibrils. In addition, this will contain actin and myosin filaments. These filaments slide in and out between each other to form a muscle contraction, which is referred to as a sliding filament theory. So the myofibril, which is a cylinder-type feature which runs through the length of the muscle fiber that contains actin and myosin. Sarcomere, which is a unit of myofibril, divides into I, A, and H bands. The actin, which is a thin protein filament, protrusions which is known as binding sites. The myosin, which is a thick protein filament known as myosin heads. Tropomyosin, which is an actin binding protein, it binds together with the actin, which helps to regulate muscle contraction. And lastly, the troponin. So this is a complex of three proteins that are attached to tropomyosin. So, building on from this, Huxley 1954 states that the theory begins with a nerve impulse that is sent from the brain to pass a message to the muscles to contract a response. This then triggers an action potential at the junction, which is located between the nerves and muscles. A chemical called acetylcholine, which theoretically helps the action potential to pass over to the junction, to be able to carry out a release that carries the action potential to the junction. Once this has happened, the action potential passes through the transverse tubules towards the sarcoplasmic reticulum, for which stimulates. And lastly, the motor neuron. The motor neuron originate within the spinal cord and muscle fibers to be able to facilitate the muscle contraction, and with muscle spindles, this will be able to modify proprioceptive sensitivity. It is also a specialized nerve that initially transmits electrical impulses from the spinal cord within the muscle tissue to enable the muscle contraction. And then, as you can see, these are all my references to support this document.